All right, and this is going to kick off our next unit, which is going to deal with polynomials first, operations on polynomials, and factoring, and then we're going to shift into quadratics. So what we're going to start with is adding and subtracting polynomials. You can see this is standard 15.1. All right, and you really have been kind of adding and subtracting polynomials already. We just have not necessarily called it that. And to kind of get you thinking about what this might be and how it might be connected to things you've already done, we have 3 problems for our opener here. So what I would like you to do is just go ahead and pause the video and then just simplify these 3 expressions by combining like terms. So do that real quick and then flip the video back on and we'll see how you did. All right, so here is my work, and hopefully my work matches your work. But if you look here, all right, 10x plus 12x is 22x. All you're doing is combining like terms. And remember, like terms have the same variable to the same power. All right, so then when I look at our middle problem here, negative 2x plus 9x, those are our 2 like terms, and I combine those, I get 7x. And notice there's not a number to combine 6 with, so I just bring it down. And then on our last problem here, notice we have 3 sets of like terms. We have an x squared and a 3x squared, which gives us 4x squared. Then we have 4x plus 7x, which is 11x. And then we just have the one number here, and we bring that down. All right, and so that's just combining like terms, which is all you're doing when you add and subtract polynomials. All right. The difference is just kind of basically how the problem is arranged and given to you. All right. So notice we could have made this 2 problems, right? I could have had this like, oh, what if I did x squared plus 4x plus 7x plus 3x squared plus 1. And if I'd given it to you in this form, this would have been adding polynomials. All right. So I have a polynomial here. I have a polynomial here. I'm adding them together. All right. So adding polynomials or subtracting polynomials is no different than combining like terms. All right, so let's take a look at that. Now, the biggest mistake, all right, okay, when we add or subtract polynomials is losing terms. So I'm going to do a couple different things here to show you kind of how to keep track of that. So one is, all right, stacking your terms, all right, to make sure you count for everything. All right, so now if I look at number 1, all right, I have my first polynomial here, and I'm just going to rewrite that. So 5x squared minus 3x plus 7. All right. Now I'm going to add the second polynomial. So what I'm going to do now is I'm just going to stack the like terms below its pair or its counterpart here. So 9x squared would get paired here. 2x would go here. And then 7 would go here. And this just helps me account for everything and make sure I line up all my like terms. And now I just add everything. All right. So 5x squared plus 9x squared would be 14x squared. Negative 3x plus 2x is negative 1x, or just negative x, and then 7 plus 7 is 14. And there's my answer. I'm done. There's nothing else I need to do. Now, I'm going to go back to the directions here. It says write each answer in descending order when possible. Now, what that means is based on the power of your variable, we want to write it from the highest power of your variable to the lowest power of your variable. And that's another reason to stack these, because then it allows you to stack them in order. All right, and then naturally your answer then in which you combine like terms will be in descending order, because notice the polynomials given to you both were in descending order. Power of 2, power of 1, no power. Power of 2, power of 1, no power. But that's not always going to happen. Sometimes they're mixed up, sometimes they're not in order, sometimes you're missing terms. All right, so this allows you to kind of look at everything and then line them up, all right, and account for everything. Okay, so now let's look at number 2. So notice my first polynomial here. I have y cubed minus 4y squared. I do not have a y term, and then I have a negative 2. So I'm going to write those out. Y cubed minus 4y squared. I'm going to leave a little blank here in case, all right, my next polynomial might have a y term, even though this one didn't. Now, here's the other benefit of stacking, is when I subtract, that means I have to change the sign of everything behind the subtraction, because I'm really multiplying negative 1 into this, which is partly the distributive property if I wanted to do that, right? I could distribute this negative 1 here. So when I do a negative times a positive 6y cubed, it's really a negative 6y cubed. And then a negative times 4 is negative 4. And then notice I'm going to put that under the number. And here's what I mean by things being out of order, right? So this allows me to kind of move things around, line them up, make sure I get like terms with like terms. And then when I subtract a negative 6y squared, that becomes a positive 6y squared. So notice this allows me to account for everything. It allows me to distribute that negative. It allows me to line everything up and make it a little bit of a smoother process to account for everything and make sure I do everything that I need to do in the problem. So now I just add up. So 1y cubed minus 6y cubed is negative 5y cubed. Negative 4y squared plus 6y squared is 2y squared. There are no y's, all right? So I can just leave that blank, and then negative 2 and negative 4 is negative 6. And there's my final answer. All right, so the stacking method allows you to kind of like account for everything, double check everything, and then easily put things in descending order when possible. All right, so now let's look at problem 3. All right, so negative 9r cubed plus 2r minus 1. So I'm going to just write that out in order. So I have an r cubed. I'm missing an r squared, so I'm going to leave a little space just in case. I have a 2r, and then I have a minus 1. And here's why. Now notice my next one I'm adding, so I don't have to worry about changing any signs. I have a 5r squared. So I'm going to put that right here, all right, in that slot to account for that. And then I have a plus r, which goes with the r, and then I have a plus 8. And so once again, you can see that this method allows you to account for everything, place everything, and then now if there's only one of such terms, I just bring it down. So 1, all right, r cubed term, so that's just negative r cubed. 1 r squared term, so I can just bring that down, that's 5r squared. And then 2r plus 1r is 3r, and then negative 1 plus 8 is positive 7. And then that is our final answer. Okay, now let's look at number 4. All right, now notice in number 4, we have 2 types of variables. So now, when you have 2 types of variables, like terms have to have the same variables and the same powers. So notice this is x to the first power, y to the first power. So that means I have to have another x to the first power, y to the first power to combine it with. Okay, so notice here, this is an x squared y to the first power. I can only combine that with something else that has an x squared y to the first power. All right, now this is when we say descending order when possible, because you may not be able to do that for both variables. You can pick one variable and then write it in descending order, right, or not. So this is where your final answer is going to be maybe in different ways or written in different ways, and that's totally fine. Now I'm going to try to put things in order by power of x. So when I look at my first, all right, expression here, I have an x to the 4th, so I'm going to write that negative 7x to the 4th. Now notice when you take your term, you always take the sign in front, so negative 7x to the 4th. Then I have an x squared term, so I'm going to write that next, 8x squared y to the first power. And then I have my 1, so plus 1xy. All right, so now when I look at my next set of terms, I'm subtracting these. So when I subtract 6x squared, that becomes negative 6x squared y. And so I have to line that up with this term. It's another x squared y. So minus 6x squared y. All right. And then now notice here, I have an x to the 4th y squared. I don't have an x to the 4th y squared anywhere here. So I'm just going to add another column here at the end. And when I subtract that negative 4, that becomes a positive 4x to the 4th y squared. And then I have an x to the 4th, which matches this x to the 4th, right? So I can line those up. So now when I subtract that positive, it becomes a negative 7x to the 4th. All right, so now negative 7 and negative 7, that's negative 14x to the 4th. 8 minus 6, that's a positive 2x squared y. All right, and then I have one of these terms, I bring it down, and I have one of these terms, so I'm just going to bring it down. All right, and there's my final answer. All right, now, once again, you may have these in different order. That's fine. As long as you have these 4 terms, technically you are correct. All right, so even if they're in a little different order, that's totally fine. So if you're checking your answers, all right, so we say we want it in descending order when possible. So try to do that. And we're mainly getting you to do that because that's typically what happens on a standardized test, right? SAT, ACT, PSAT, you're probably going to see your answers in standardized or on a standardized test in descending order. All right, but okay, know that that's not necessarily incorrect. All right, let's do one more here. And now, when we look at number 5, notice sometimes we add or subtract multiple polynomial expressions. All right, now this is where I really find the stacking is very useful. All right, because when you start getting to 3 or 4 different expressions that you're adding or subtracting, it sometimes becomes hard to keep track of all the different terms. So I'm going to start with my first term here. I have a 4x to the 4th. I'm missing an x cubed term, so I'm going to leave a space, and then I have an x squared term, an x term, and then a number term. Now I'm going to go to my next one. Okay, I'm adding these, so I don't have to worry about changing sign. I have an x cubed term, so I'm going to put that in the empty slot here. Another x squared term, so I'm going to line that up with the x squared, an x term, and then my positive 1 here. And now I'm subtracting my last polynomial here, so I have to change all the signs. So when I subtract positive 5x squared, that becomes negative 5x squared. When I subtract 9, that becomes negative 9x. And then when I subtract 8, that becomes positive 8. And then now, once again, it's very easy to see my like terms, account for them, and add them up. So one term here, bring it down. One term here, bring it down. And then -9 plus 8 is -1 plus -5, so this is -6x squared. 8 minus 3 is 5. 5 minus 9 is -4x. And then -7 plus 1 is -6 plus 8 is 2. And there's my final answer. All right, so now to wrap up. All right, one more detail here. I should have maybe mentioned at the beginning, but hopefully you see this, is that when we combine like terms, the term does not change. Whatever term we start with is what we finish with. All right, so notice we have x squareds, we have x squareds, I end with x squareds. I have an x, I have an x, I end with an x. All right, and this should make sense to you, all right, because just think about when you're adding any particular thing, right? So if I have 6 pens and 5 pens, I end up with 11 pens. They don't turn to pencils. All right, if I have 6 apples plus 4 apples, I get 10 apples. They don't turn into bananas. All right, so when you're combining like terms, all you do are grouping the same types of things, and those things stay the same. All right, so that wraps up our lesson on adding and subtracting polynomial. As always, if you have questions, make sure you write those down or highlight those problems, ask those in class, and we'll see you next time.